Hello everybody and welcome back to another episode of How to CMake Good. It's been a little while since the last one, but we're gonna just pick up where we left off and do a bit more scripting discussion. This episode's going to be a bit of a smattering of a few different subjects, mostly some important variables, directories, and how they interact with the project and add subdirectory commands. They're important to be aware of when writing your CMake projects. I had the simple Hello World project that we did last time, and we're going to continue with it as an example for today. I've made a few minor modifications. In the root CMake lists, we have a project call, and in these subdirectories, say hello and hello exe, we also have a project call. In say hello, that is hello library with the version 139. In hello exe, it is hello program version 201. I've also written this small script called print variables that we're going to use to print out some important variable names and see how they're affected by the current directory and project. These variables are CMake source dir, CMake binary dir, project name, project source dir, project binary dir, project version, CMake current source dir, and CMake current binary dir, as well as CMake current list file and CMake current list dir. It's important to know what each of these does as they have important implications in how you write your scripts. You can see in my editor if I hover over a variable name it's giving me help, which will be a good reference if you need quick information on what each of these variables means. We can give you a quick rundown. CMake source dir is the top level source tree. Binary dir is the top level of the build tree. Project name is the name given to the most recent project command, where most recent means the most recent in the current directory or parent directory. Project calls in subdirectories do not affect the value of project name, project version, or project source or binary dir in the parent directories. Project source dir is the source directory where the most recent project occurred. Binary dir is the binary directory corresponding to the source directory of the project. Project version is the version argument given to the project call. Current source dir is the current CMake lists.txt directory. The current binary directory is the binary directory that corresponds to that source directory. The current list file is the current CMake script that is being parsed and processed. The current list directory is the directory that contains that file. Talking about them is easy enough, but I've written this in a function that we can use to print out and see what they are. I'll go to the top level CMake lists and I'll include that script so that I have the definition of the function. Include is a very important command, but I'll be going over that in a separate video. All I have to do to use the function is simply call it. And then when I run my CMake configure, we'll see the variables it prints. The CMake source directory is the directory that owns this CMake lists.txt. And we can see the binary directory is the build directory I've set. It's important to note that this CMake source directory never changes once CMake starts executing. It always refers to the directory in which the top level CMake lists.txt was found. If I run CMake from the command line and I pass in a source directory like this refers to the directory that will be used as CMake source directory, as well as the entry point for the CMake project. Using CMake source directory will be able to get you the full and absolute path to whatever the user passed as the source directory when they invoked CMake. CMake binary dir has a similar correspondence as the directory in which the CMake command was run, and the top level directory in which build results will be placed. Just like CMake source dir, CMake binary dir will never change once CMake starts executing. If we go back to the output, we can see that the source directory for the top project is the same as the source directory for the entire CMake execution. That is because this project call appears in the top CMake lists.txt. The binary directory is the same as the binary directory for the top level CMake lists.txt as well. We see that the current source directory is the same as the project source directory, and the current binary directory is the same as the project's binary directory. The current script file, as in the one in which this message command was evaluated, is this CMake lists.txt, and the current script directory is the directory which contains that script. That's simple enough, but we see it change once we start to go into subdirectories. I'll open up hello exe and I'll add a call to print variables here and take the one out of the top level directory. Now we see that the CMake source directory did not change from what its value was before we did the add subdirectory. It never changes. The source directory of this hello program project, though, is now the subdirectory that we added from the root. The binary directory of the project is also a subdirectory, just like the source directory is the subdirectory of the parent. The source directory of the project corresponds with the current source directory in which the project call appeared. The current source directory is changed whenever you call add subdirectory, and it is restored when add subdirectory returns. A relative path passed to add subdirectory causes that relative path to be appended to the current source directory to form the new source directory. That relative path is also appended to the current binary directory in order to form the new binary directory. The add subdirectory call also accepts a second argument, which lets you specify a different binary directory than the default one that is implicitly generated. Now, the source directory for this add subdirectory is unchanged, still hello.exe, but the binary directory for this project is now example binary subdir. Hello.exe does not even appear in the path. Just to show that these values are restored when add subdirectory returns, I'll add another call at the top level. So we've run print variable twice. The CMake source directory is the same in both instances. The source directory of the first call, which appears in a nested subdirectory, once add subdirectory returns, the source directory now refers to the top project, which is the most recent call in the current source directory. It does not take into consideration project calls in subdirectories of the current source directory. I'll take those out and show another example of how this works. If I move the print variables call above the project call so that the project variables have not yet been set when we evaluate this function, we'll see some different values. The source directory still refers to the top project, even though we are in the subdirectory that contains the new project. This is because we have not yet evaluated this project call. So the source directory of the project still refers to that top directory. However, we have evaluated add subdirectory, so the current source directory is the directory that contains this CMake It is only once project is called that the value of the project source-dir changes. Just a reminder, pull open that print variables again. The project source directory is stored in this project source-dir variable, which is only updated when we call project. The CMake source-dir refers to the top level. The CMake current source-dir refers to the current level. We haven't talked about the include command yet, but it's important to see how that affects these variables too. I'll write a simple script that we include in this subdirectory project. I'll define the something.cmake, and in it, I'll simply call print variables. So now, the path of execution is enter the root CMake lists, add subdirectory into hello.exe, go into the CMake lists.txt for hello.exe, include something.cmake, which will transfer control into the something.cmake script, and then we will call print variables. The result is a little different. The source directory, of course, is still the same. The source directory of the project is still hello.exe. The source directory is unchanged. The binary directory is unchanged. The current script file has changed to something.cmake instead of cmakelists.txt. This is important as it's the current script file, not the current cmakelists.txt. I'll do another experiment. I'll add an additional subdirectory. I'll call it subdir. I'll move something.cmake into that subdirectory, and I'll update my include statement to go and find it in that directory. Now, if I run configure the source directory, unchanged. The project source directory, unchanged. The current source directory is not the subdirectory that contains something.cmake. It is still the most recent directory added by add subdirectory. Including files in different directories does not affect the source or binary directory. However, the current script file, something.cmake, is in the subdirectory, and the script directory is the subdirectory in which this file appears, even though there's nothing else in this subdirectory other than the one something.cmake. As a refresher, the CMake source directory is spelled CMake source-dir. CMake binary dir is spelled CMake binary dir. The project source directory is spelled project source-dir. Project's binary directory is project binary dir. The current source directory created by the most recent add subdirectory or the top level CMake source directory in case add subdirectory has not been called is CMake current source-dir. The binary directory that corresponds to the source directory is modifiable by the user in the add subdirectory call, so it's important to always evaluate CMake current binary dir when you want to know where the binaries for the current directory live. The current script file is spelled CMake current list file, and it always corresponds to the absolute path to the current CMake script file being evaluated. The script directory is always just the directory that contains the CMake current list file, and is spelled CMake current list dir. As the last tidbit, some of these variables can also be used in CMake scripting mode, where you run a script with CMake-P. If I add a call to print variables within the print variable script itself, and I then evaluate that script with CMake-P, we see values for the variables we've listed. The source directory is the current directory in which the CMake script was executed. The binary directory is always just the same as the CMake source directory. The current source directory is just the source directory. The binary directory is just the current binary directory. The script file and the script directory have not changed significantly. There are no values for the project variables because the project call is not allowed when running CMake in scripting mode. If I cd into the build directory and I run CMake-P print variables again, you see it changes to the current working directory where I ran this script, not the directory that contains the script. That's most all there is to know about these several very important CMake variables that everyone should know and understand. I know it's been a while since the last installment, but I've been pretty busy, but I hope that it won't take me as long to get the next episode out. Also, I now have a Patreon page where you can help support me and make more videos like this possible. I'm only one person, and I also have a full-time job, so I have to do this in my free time. I'm incredibly thankful to all of my current contributors for encouraging me to make more videos, make more tools, and keep working on what I do. If you like what I do and can spare a bit of money, you can donate and get some nice rewards, including up to prioritizing items in my GitHub backlog, or request topics and text tutorials, and even code reviews. I hope it won't be as long until the next installment, but until then, keep CMaking good.